Welcome to another PsychoPy mini tutorial. Today we're going to be looking at how to get typed answers from your participants. So normally in PsychoPy, when you add a keyboard object to a routine, and I'll go ahead and do that right now, you can allow individual keys to be pressed, and you can log which key is pressed. So this is very handy if you want to have a trial where you give participants a couple of decisions to, or a couple of possible responses to make, such as a yes-no decision. And you can log if a participant says yes or no. But what if you want to actually give a participant the ability to type in a full response? So for instance, what if you're doing a recall experiment and you want to allow subjects to type in a word on a particular trial? How would you do that? Well, it's actually not that difficult to do. What you do need to do is insert a keyboard object, but you're going to need some custom code to both display what participants are typing on the screen to give them feedback, and to actually keep track of what they're typing and accept their final response. So let's actually insert this keyboard object. We'll call this the key response. And under allowable keys, we're actually going to accept every single letter of the alphabet. Now, this is going to take me a while to type in, so I'll skip ahead here. But if, for instance, you only wanted participants to type in numbers, you could include only numbers. So you could include 1, 2, 3, etc. We're actually going to stick with letters, so we're going to allow participants to type in full words. So let me fill this out here. Okay, so I've entered all the letters of the alphabet. I'm going to enter 2 more potential keys. We also want participants, in this case, to be able to press backspace. This will allow participants to correct mistakes that they've made, and I'll show you how to deal with that. And we're also going to include return, because we want participants, when they're done typing in words, to press return. Now, 2 other things you have to change on your keyboard object here. Normally, when participants press a key, you want the routine to end. But in this case, because we're allowing participants to type in a response, we don't want the keyboard object to end the routine as soon as a button is pressed. So you want to uncheck force end of routine. Second, you don't just want to store the last key that was pressed. You want to store all keys that were pressed, and we'll see why that's important later. But you can intuitively figure this out. If a participant typed in a 10-letter word response and then pressed enter, if you left it on last key, all that would get stored would be enter, because that is the last key that is pressed. And that's not going to be very helpful in helping you figure out what was actually typed in. So we actually want to store all keys. So now in our little dummy trial here, we have our key response. Next, we're going to add in a text object, and this will be our feedback area where we're actually going to show participants what they're typing in. So this will have an infinite duration, and what we actually want to display is the key response dot keys. So the keys property of key response is going to be a list of all the keys that were pressed. However, we can't just leave this in, because if we were to do this, and before we run our experiment, we're just going to save it. We'll call this free recall. If we were to just run our experiment as is right now, what you would see is that we are literally showing the word key response dot keys. So we need to do a little bit more here. Okay, so if instead of just displaying the word key response keys, we actually want to display the value, we're going to add a $sign here. Oh, and one more thing we need to do, because this is a variable that we're now trying to display, we actually need to switch this to set every frame, basically meaning update this variable's value every single frame. So go into the key response, figure out what keys have been pressed, and update that every single frame that you are displaying on the computer monitor. So we'll go ahead and leave that. Now, if we run this as is, what you'll see is we can actually now see what participants are typing in. So as I am typing letters, you can see it's even tracking when I press backspace, and so on. Now, of course, we were seeing the buttons that were being pressed, but obviously they weren't being displayed in a way that we want to show to participants. I mean, every letter was isolated. It was kind of being presented in a computer list. So we got to get rid of all that stuff. So if we want to get rid of all that weird list stuff, all we have to do is change our code to be 2 apostrophes, period, join, and then in brackets, have our keys. What this is doing is telling Python to create an empty string and then join onto that string all the contents of your keys array. So remember, the keys is going to be a list of all the keys that have been pressed. And if we're joining those together into an empty string, they're all going to be pasted one after the other, and it's going to create a nice string of letters that we can then read. So if we go ahead and run our script here, what we see is this is me typing. And you can see I'm actually typing keys. Now keep in mind, we did not include spacebar as a valid key, so you see I can't press spacebar. Also, if I press backspace right now, look, it adds the word backspace, and I press return, it adds the word return. So we're going to have to add a little bit of code to deal with backspace and return. But we're getting very close to being able to accept our keyboard input. So in order to finish dealing with our keyboard input, we actually need to add some custom code. So I'm going to go ahead and add a code object here, and we will call this the recall code. Now, when you add a code object, you can now insert actual Python code into your script. We can add that code at the very beginning of the experiment, which is not what we want in this case. The beginning of the routine, meaning when this whole routine starts, before a word is actually displayed, before keyboard input is drawn, we can add some code. That's not what we want. Instead, we want some code that will update every single frame of the experiment. So first, let's add in a bit of code to deal with backspace. So we're going to have an if statement that checks to see if backspace is in the keys, is in the list of keys. So if backspace is in the key response list of keys, then what we actually want to do is remove backspace. So that keys.remove backspace. So this will, what it will do is it will look to see if backspace has been pressed, and if it is, the first action it will take is it will remove backspace. The next action we want to take is to remove the very last pressed key. So what we can do is go key response keys dot pop. Now pop is a function that will pull the very last item of a list off, and normally you can read that in if you want to do something with it. But for when we're pressing backspace, we just want to get rid of it. So just calling the function will take that very last key that was pressed and just get rid of it. Now we're actually going to add one little condition here, because if we just left things as is, then in theory, if the very first key a person pressed is backspace, let's say that nothing had been typed in and the person typed backspace, then we would remove backspace. We would then try to remove the last letter that had been typed in, but there'd be no more letters to return, and so we'd actually get an error here. So we actually only want to get rid of that last key if the length of key response.keys is greater than 0. Basically, as long as there is at least one letter that has been typed, then you can go ahead and get rid of the very last letter that we've got. And that's it. This code will deal with backspace. So let's see it in action. We'll go ahead and click run here. And now, if we type in a word, now if I press backspace, notice that the words are being removed. Also notice though, that backspace is very briefly being flashed on the screen every time we press it before it's being removed. So we're going to have to fix that too. All right. So in our text object, we were actually creating the string of what to show on the screen from the keys right there in the text object. But what this does is it means sometimes we'll create a string that will include all the keys before we actually have gone in with our code and dealt with backspace. So here's what we're going to do. We're going to take this code that was displaying text on the screen, and we're going to cut it out. And we're going to say, let's have a new variable here called screen text. And we'll say OK. Now I'll go into my recall code here. And what I will do is I will actually create screen text out of what we used to be showing directly on the screen. So what this does is it means that first in our code here, we're going to process the backspace, deal with the backspace, and then we're going to create a variable called screen text that is made out of all the keys remaining. In this way, if the backspace key is pressed, that's not going to show up on the screen because screen text won't update as soon as the backspace key is pressed. Instead, this whole script will run at some point. It will find the backspace, remove it, remove any keys it needs to, and then it will create this variable called screen text out of the remaining keys. So this will protect us to make sure backspace no longer flashes on the screen. And one thing we're going to do is at the very beginning of the routine, we're actually going to create screen text as well, and we're just going to have it be blank. This way, if the text object tries to display screen text, if this script hasn't run yet, there's not going to be any value set for screen text, so the program could crash. But if at the very beginning of the routine we just set up screen text to be blank, then that will protect us and make sure that as soon as this tries to display screen text, it will find a blank string that it can just show on the screen. Okay, so if we click run, oh, we actually get a little error. I made one little mistake here. If we go back into each frame, we can get rid of this $sign and we should be good. And off we go. So now if we type, we can press backspace, and notice backspace is no longer flashing on the screen. Great. We are in the home stretch here. Now what we have to do is deal with return. And you can probably guess that some of what we did when we dealt with backspace is going to come back up when we're dealing with return. So let's expand our if statement. First, we're checking if backspace is pressed, but if backspace wasn't pressed, let's look for return. So if return is in key response.keys, then we still want to remove, keys. We still want to remove the return key because we don't want that to be part of our output. But now we're going to set a variable called continue routine to false. So what is continue routine? Continue routine is a variable that PsychoPy uses to determine whether it should keep running this routine. So if we set it to false, then PsychoPy will know to end this trial. So let's go ahead and give that a shot. So this is my string, and I'll press return, and you can see that the experiment ends. If we go into our data file for our free recall experiment here, what we can see is all the keys that were typed. We can see the reaction times of when each of those keys were pressed. But we actually, in our data file, do not have like a nice clear logging of the actual string that was typed. So we're actually going to manually add in one more column here using script that will log in the precise thing that was typed. So going back to our script, there's one more thing we need to add in order for this free recall to work. At the very end of the routine, we actually want to log screen text. So all we need to do in order to log screen text is to add some code in this if statement. So when return is pressed, don't just remove return, but add data, and we'll call this recall response. And what we're going to add is screen text. What this function here does is it adds a new variable to the data file that is being produced. It calls it recall response, and the value that it logs is whatever we've got in screen text. And if we want, we can even go ahead and have screen text refresh itself, be nice and fresh, nice and updated, so that it is being logged correctly. And then once again, the routine will then end. So we can hit OK. And if we run the experiment from here, we can type in some value, press enter, our experiment ends. We open up our data file, and lo and behold, we have a nice clear input of what was entered in the recall response. Now, of course, you could go ahead and insert a loop around this. You could end up creating a test phase. You could have participants typing in a series of responses. If you want, you could add another text object to this routine, and you could say, please type in your response, and you could position it on the y-axis so it's above the point where participants are asked to type, and actually you want to make that infinite duration. And so you can make a series of changes here in order to dress up your recall response, but at the core, the code that I've shown you is all you need. Now, a few things to keep in mind are that when I was inputting letters into my keyboard object, I used all lowercase letters. If I used uppercase letters, then you would have to have subjects run the experiment with the caps lock on. So if you were paying attention in this video, all the letters that I typed in were in lowercase. If I had put uppercase letters here, I would have had to turn the caps lock on. There's other little tricks you can do, for instance. So you could also set things up to check to see how many letters participants had typed in. So for instance, maybe you want to set a limit so that participants can only type in 10 letters at a time. So if the length of key response keys is greater than or equal to 10, then key response.keys.pop. This little addition of code would check to see if 10 or more letters had been pressed, and if so, it would remove a letter. If we go ahead and hit enter and then run our experiment, we can go ahead and see that we can't type now more than 10 letters. So if we type a bunch of letters, I'm continuing to try to type and notice how it's really not letting me. You could set other restrictions in your code. So you could go in and when somebody presses return, you could check to see here if length of key response.keys is greater than 2, then do all this. And what this will do is when a subject presses return, it will remove the word return from their response, and then it will go and check and see if they've typed in more than 2 letters. And if that's true, then the subject can actually log the data. But if not, it won't let the trial end. So if we go ahead and I am missing a parenthesis here. Always make sure if you're opening a parenthesis, you are closing it. Once again, we're checking to see if at least 2 keys have been entered. And if we go ahead and run this, we won't be able to press enter until at least 2 letters have been typed. So if I type in a letter like F, and I press enter, nothing is happening. F again, nothing is happening. F again, now enter will be accepted. So you can go ahead and create little restrictions on your recall responses, but this is pretty much it. The only other thing I can think is if you potentially wanted subjects to be able to enter space, you would have to include space as a valid key, but you'd actually have to have a little bit of code here. So let's go ahead and insert it here. Let's say if space is in key response.keys, you would actually want to remove space, and you could go ahead and push an actual space at the end. So if we hit OK and then we run our experiment, we should be able to actually now type spaces. This is a test. Oh, and I can't type more than 10 letters. But you can see that now I can include spaces. So those are all the tips and tricks you can use to actually have participants type in responses in PsychoPy. I hope this helps expand what you can do with PsychoPy. And yeah, good luck with the coding. So this has been a PsychoPy Quickie, and I hope it helps.